Andre Marie Ampere discovered the concept of electric current, and Alessandro Volta discovered the concept of potential difference in the conductors. The rate of flow of electric charges was called electric current. I is equal to Q upon T. And potential difference between 2 points of electric circuit carrying some current as the work done to move a unit charge from one point to another. Electric potential difference V is equal to W upon Q. The problem was that the electric current flowing in the conductors was not same in all conductors, and the scientist whose name was George Simon Ohm discovered an experimental law that is called Ohm's law. It was the year of 1927 when he provided his law. It was very popular law and became the milestone in the development of electric circuit. George Simon Ohm provided the concept of electric resistance in the conductors. According to Ohm's law, when physical conditions of a current carrying conductor does not change, the potential difference B between 2 points is directly proportional to the electric current. Physical properties of the conductors means temperature, length, thickness, volume, etc. Here is a conductor AB in which I current flows and potential difference between 2 points A and B is V. Now the Ohm's law says that V proportional to I and V is equal to Ri, where R is a constant. It is called resistance of the current carrying conductor. R can be written as V upon I. The unit of resistance is ohm. The symbol is such type, and the unit is also called volt per ampere. The reverse of electric current R is called electric conductance, and it can be written by the G, capital G, and capital G is equal to the 1 upon R. The unit of electric conductance is ampere per volt or ohm inverse or mho. Later, it was discovered that all the conductors do not obey Ohm's law. So all conductors were divided in two categories. First, ohmic conductors or linear conductors. The conductors which obey Ohm's law called ohmic conductors. The VI characteristic curve for those conductors was such that a linear line, so those are called linear conductors. Examples of ohmic conductors are torch bulb and the copper wire, aluminum wire, etc. Second, non-ohmic conductors. The conductors which do not obey Ohm's law are called non-ohmic conductors or non-linear conductors. The VI characteristic curve for those conductors was not a linear line. This is the characteristic curve of diode, which is non-ohmic conductors or non-linear conductors. Examples of non-linear conductors are diode, triode, transistor, and amplifier. Now we will study some questions which are asked in last year CBSE class 12 science paper. There was a question in 2020. State the relation correlating the electric current flowing in a conductor and the voltage applied across it. Also draw a graph to show this relationship. The question is asked about the Ohm's law, and we will discuss the Ohm's law in the answer of this question, and the graph will be shown as the ohmic conductors. Second question was asked, find the resistance of a conductor if electric current flowing it is 35 ampere when the potential difference across it 1.5 volt. The numerical question will be solved as I is equal to 0.35 ampere, V is equal to 1.5 volt is given. What will be the value of R? We will apply Ohm's law. R is equal to V upon I. and we will put the value 1.4 upon 0.35, and it will come out 140 upon 35, and that will be equal to 4 ohm. Now see the some important questions. What is 1 ohm resistance? 1 ohm resistance is called when 1 ampere current flow in a metallic conductor when potential difference across 2 points is 1 volt. Question number 2. If V is 140 volt and I is equal to 0.35 ampere, what is the value of resistance in the circuit? Same type of questions we solved here. R is equal to V upon R is equal to V upon I, and that will be 140 upon 0.35. We will solve this 14000 upon 35, and that will be 400 ohm. That will be the answer. There is also an important question. Some BI graphs are given. Classify them in linear and non-linear conductors. A graph is of such type. This is not linear. This is non-linear. And B, the graph is also non-linear. C, that is also non-linear. And D, VI graph is linear because that is a straight line, and the graph shows the conductor follow the Ohm's law. Question number 4, that is also an important question. There are two electrical circuits. A is such type, 6-volt battery is connected here, and 2 ohm resistance is connected in the circuit. What is the value of I? What is the value of I in figure A? Well, we know that R is equal to V upon I, and I can be written as V upon R. I is equal to 6 upon 2, that is 3 ampere. In the second circuit, two resistances are connected in series. The total resistance will be 2 plus 1, that is 3 ohm. 0.5 ampere is flowing in this circuit. We have to calculate value of E. We know that R is equal to V upon I. We will write 3 is equal to E upon 0.5. So E is equal to 3 into 0.5. That will be 1.5 volt.